going to start off by taking a look at section 11.1, which is on sequences. So basically, a sequence is just a list of numbers. You might remember from Algebra 2, sometimes you add the numbers up. That's the next step. That's called a series. Okay, we're going to look at a series tomorrow. But a sequence is just a list of numbers. Usually the way that we name a sequence is with a lowercase letter. And here's an example of a sequence. If the name of this sequence was B, then we would call the first term B sub 1. B is the letter for the sequence, and the number tells you the position you're at in sequence. So B sub 2 means look at the sequence that we're calling B, and the 2 means look at the second term. So this one, for example, would be B sub 3, and so on. And there's a couple different types of sequences. There's sequences that go on forever, and then there's sequences that stop. This particular sequence stops at the nth term. How high is the nth term? I don't know. They didn't give us a value, but it does stop somewhere. If you see a dot, dot, dot as the very last thing in a sequence, then that means it goes on forever. So that would be an example of something that's infinite. This keeps going forever. Right, any questions on how we name a sequence using that notation? All right, so how about Dominic, if I was going to name this next term, what would that one be? Yep, B sub 4. Very good. So in order for a sequence to be unique, because some sequences might be the same as other sequences. Like if you had this sequence, and I had this sequence, those sequences would be the same thing. You're just looking at different parts of the same sequence. The rule here is you're just adding 2 each time to get from one number to the next. Well, if we're talking about 2 sequences, you'd have the same formula to find the numbers in this sequence compared to the numbers in this sequence. They're just different. It's like you started at a different point. But in order for a sequence to be unique, there has to be a formula for finding any term that you want in the sequence. Now, for this one, if I said to you, how many have I got? 1, 2, 3, 4. I got 5 terms. If I said to you to find like the 8th term, that wouldn't be that big. Okay, all you'd have to do is add 2, 3 more times, and you could get the 8th one. But if I said to find like the, say, 4,000th term, you really don't want to sit here and just add 2, add 2, add 2, and write every single one down. Okay, we want a faster way to do it, and that's what we'll talk about. So for a sequence to be unique, there has to be a formula for finding the nth term in that sequence. And when they say n in a real problem, they'll give you a specific value, like find the 12th term. They'll tell you which one they want. All right, so let's look at that sequence. Now, I haven't really shown you guys how to do a formula or anything fancy. There is a way to do this problem and find a formula using a method. But I just want to look at it and see if anybody can tell me what it looks like the pattern there is. Yeah. +3. Yeah, +3. +3 to what? So like if you wanted, let's call this one a sub 1, and let's call this one a sub 2. how did you get a sub 2? You said plus 3.
You added 3 to the first term.
You added 3 to a sub 1. So a sub 2 is the one before it plus 3. So how do you think we'd write the formula for a sub 3?
A2 plus 3.
Yeah. You take the one before it and you add 3. So if you want to know the third term, you take the one that's before it, you take the second term, and then you add 3 to it. The one before it is 5. When you add 3, you get 8. Let's do one more, and then we'll see if we can generalize it.
A sub 3 plus 3.
So this one would be a sub 3 plus 3. To get the fourth term, take the third one and add 3. So the rule is you take the one before it and add 3. So now, let's see if we can do it right here. A sub n. What do you think the one is before a sub n? Well, this is a more general one, so we don't know exactly what position a sub n is. It would be a sub n something, but we need something else down here. What would come before, like if you wanted to know before something, what would you do?
Is it on the bottom n minus 1?
Minus 1, yes. In general, to get the one that you want to know, take the one before the one you want to know, which is represented with that minus 1, that means one before, and add 3. Now that's a perfectly good formula for that problem. But does anybody see an issue with a formula like this? It depends on the one before it, and then all you have to do is add 3. Adding 3, that's easy. But any issue with that formula? Sam?
Might not give you the one before it.
Right, what if you don't know the one before it? Like what if I said to you, find the 897th term? Okay, we'll take the 896th one and then add 3. Well, what's the 896th one? Well, now you need the 895th one and then add 3. So this formula is okay, but the downside of it is you need to know the one before it to get the next term. So let's see if we can think of a different way. So think of this formula as 2 is in the first spot, 5 is in the second spot, 3 is in the third spot, 11 is in the fourth spot. Can anybody see a pattern where you do something to this number and it turns it into that number? There is a pattern, and it's the same pattern. If you take 2, there's something you can do to the number 2 to turn it into 5. You might think, well, let's just try and add 3, right? So if we just take this 2 and we add 3, we get 5. So let's try the next one. If we take 3 and add 3, do we get 8? No. So we're trying to find something we can do to the position number. So like if I wanted the 500th term, I could do something really quick. See?
So you could double it and then plus 1, but then the next one you just double it and plus 2.
All right, so it's a good thought, but if we have to keep changing it each time, then it's probably not doubling. It's going to have something to do with a 3. Yep.
Multiply by 3 and subtract 1.
Perfect. If you multiply by 3 and subtract 1, that will give you the term you want. Let's try it. What's 4 times 3? 12. And 12 minus 1? 11. There you go. Now, did I use the 8 to figure that out in any way? Bless you. I didn't use the one before it. So another formula is 3n minus 1. Both are fine. Both are correct. But this bottom one's going to be a lot easier. So now if we wanted to know, say, the 100th term, all we have to do is take 100, triple it, and minus 1. So it's going to be 299. We quickly were able to find the 100th term without finding the 99th, the 98th, and so on. So this type of formula is what we want to get. This one's okay, but the bottom one is even better. Any questions on those two formulas? Okay. All right, so let's look at two ways we can classify a sequence. I told you that some sequences go on forever and others stop. Well, if a sequence goes on forever, that's called an infinite sequence. That's called an infinite sequence. It goes on forever. Now, when we say it goes on forever, let's pretend that these are positions in my sequence. The first spot in a sequence is called position 1. There's no such thing as position 0. Okay, we don't have position 0. We also don't have negative positions. So the first spot in a sequence is positive 1. The next spot is position 2. There's nothing in between position 1 and position 2 in a sequence. It's like runners finishing a race. There's 3 people. You're going to finish first, second, and third. Nobody can finish in between first and second. You finish first, you finish second. There's nothing in between. That's why we say integers. There are no decimal positions in the sequence. Any question on the numbering there? Now, infinite means it goes on forever. Does anybody know what the word we use for it's stopping somewhere? It's part of this word. We just have to remove something, yeah? Finite, yes. Good job. Finite. So, we don't say infinite. They say infinite, that's how they pronounce it. But infinite means it goes on forever. Finite means it stops. There's a number in the first spot, the second spot, the third spot, all the way up to a certain spot. We may have a sequence that's millions or billions of numbers long. But if it's a billion numbers long and it stops, that's finite. It's big, but it still stops somewhere. And we're going to get to some examples where you guys are going to figure out some formulas, but there's a little bit more background to look at first. Does anybody have a question on the difference between infinite versus finite? Yes. Yep, you just sign up. Thank you. All right, so let's try this. They give us a formula, and it says list the first 3 terms and the 15th term of this sequence. Remember, n is the position you want to know. So if you want to know the number that's in the third spot, plug in a 3. If you want to know the second spot, plug in a 2. Okay. So it says list the first 3 terms and the 15th term. All right, let's start with the first term. Tony, if I want to find the first term, what number would I fill in for n?
1.
1. So let's fill in 1 for n. And we'll we'll do that out. Can you tell me, Tony, what's 1 squared?
One.
What's 1 squared?
1.
1. And 1 minus 1?
0.
Give me 0. And Greg, what's 0 divided by 0? So the first number in this sequence is the number 0. Okay. Second term. Fiorella, how do you get the second term?
Plug in 3 for n.
So which term are we finding?
I forgot.
So we're finding the first 3, and so far we found the first 1.
I bet. Okay. So.
Okay, so you had said we were finding the second term, so plug in
2.
2. Grady, can you just sign out one thing? All right, so let's plug in 2. So everywhere I had an n, I changed it to a 2. So 2 squared minus 1, that's in the top, divided by 2. And I heard you start to say, what does that come out to?
3.
So 3 in the top and
2
2 in the bottom. So there's the second term. And let me just move a sub 3 down a little bit. All right, 1. So to find my third term, what would I plug in for n? 3. Can you tell me what the calculation is going to look like?
3 squared minus 1 over 3.
Perfect. Good job. 3 squared minus 1 over 3. And Ryan, what's 3 squared minus 1?
8.
8
Over 3.
over 3. Okay, so there's the third one. Now, with the formula they gave me, do I need to find the 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, and 14th term to jump to 15? No, I can jump right to 15 because this is the kind of formula that allows you to do that. So, Jenna, to find the 15th term, what number am I going to plug in for n?
15.
Yep, good. I'll plug in 15. So replace n with 15. So 15 squared, yep, 225 minus 1, 224. We'll just leave it like that. So there's the first 3 terms and the 15th term in this sequence. Definitely a harder formula than I would have you come up with on your own. But in this kind of problem, I'd give you that formula and just ask you to find some terms with it. Just like that. Any questions on that? Okay. Let's try this one. So this is negative 1 to the n times 2 to the n. Just want to focus on that for a minute. When you raise negative 1 to a power, it's very limited, the answers you can get. What can you get when you raise negative 1 to a power? Asia? You can get 1, or you can get a negative 1. When do you get a 1? What kind of power could you raise negative 1 to? And it would come out to positive 1. Yep?
When power is even.
Even. So anywhere that we have an even power, this is going to turn into a 1. When are we going to get a negative number in that red circle? Yeah?
Any odd.
For any odd. So what the negative 1 to the n is basically going to do, it's going to cause this sequence to oscillate positive, negative, every other term. Right. So let's start with the first term. Tyler, what would I plug in to get my first term? Sorry, can you say it again?
Replacing the n for b.
Yep, replace n with
1.
1. Good. Everywhere you see an n. So negative 1 to the first times 2 to the first. Sky, what's negative 1 to the first power? Negative 1. Good. And what's 2 to the first power? 2. Negative 2. So there's our first term. Negative 2. All right, let's do second term. Kiana, what am I going to plug in for n to find my second term? 2. So negative 1. Change the n to a 2. And then 2. And change the n to a 2. Austin, what's negative 1 to the second power? 1. Good. And 2 to the second power? 4. And 1 times 4 is going to give me 4. And does anyone think they know what the third one's going to be without going through the formula? If we look at the pattern. If not, we'll go through the formula one more time. Negative 8. So what's happening is this 2 to the n is causing it to double. And this negative 1 to the n is causing it to alternate on, negative positive. So the next one would be negative 8. Now, to get all the way to 15, we could double it and make it the opposite. So the next one would be 16. The next one would be negative 32, positive 64. But there's an easier way to get all the way to 15. Just plug in 15. So negative 1 to the 15th times 2 to the 15th. All right, and 2 to the 15th, that's pretty big, so I'm going to use my calculator for that. So negative 1 to the 15th times 2 to the 15th. So it's negative 32,768. Any questions on using a formula to get terms in a sequence? Yeah.
I'll move.
Yep, just sign out for me.
Can I see the formula?
The formula? Yep. Again, a little more complicated of a formula than I would have you come up with by hand. Kind of ones that you're going to do is usually like double a number and add 3, or triple a number and minus 5. It's usually something along those lines. Because in general, finding a pattern for a sequence, that can be very hard, extremely hard. And that's what cryptography is based on, not being able to figure out a pattern in a sequence. Because if you can, then you can see the message somebody's sending if they're trying to encrypt it. Right, so some are very, very hard to find. So I told you when we started out, the first problem we did, we had 2 kinds of formulas. One of them was good because we could find any term we wanted directly. The other one was okay, but it depended on the term before it. The kind of formulas that we want to try to come up with are called explicit formulas. The reason an explicit formula is the easiest one is because you can directly find any term you want. If you want to know the 200th term, you can find it directly. You don't have to find anything else that comes before it. Does anybody know the name we use for the type of formula that you do have to find the one before it? It begins with an R. Not a word that comes up in math very often. It's called recursive. So a recursive formula, even though it's easier to find it, it's not as useful. Because if I gave you a recursive formula and said find the 5,000th term, you would have to find every single one before that one to get to that one. Not only does it take longer, the chances of making a mistake doing that is pretty high. Maybe recursive is okay if you only had to find like 3 or 4 of them, but if you've got to do thousands of them, a recursive formula is not the way to go. Does everybody have the top? So the way a recursive formula works is they have to tell you the first couple terms. I'd say generally 3. 3 terms is enough to see the pattern. But you'll get the first few terms. And then to get a rule for the nth term, it's usually going to be defined by using the one that came before it. Or sometimes 2 that come before it. And there's actually a pretty famous sequence. Once I say the name, I think some of you might be familiar. Does anybody know it's named after somebody? It begins with an F? That's, yep, the Fibonacci sequence. Very good. That's a sequence that's recursive. And the way you get the numbers in the Fibonacci sequence is you take the 2 numbers that are here and you add them up to get the next one. So what's 1 plus 1? 2. And then 1 plus 2?
3.
And 2 plus 3?
5.
And 3 plus 5? 8. And you may wonder, where will I ever use the Fibonacci sequence? Well, if you do an escape room in a certain location, which I won't tell you, so I don't ruin it, there was Fibonacci numbers, but they were in the thousands. And I failed to recognize the pattern, and we didn't escape because of that. And I don't know the Fibonacci numbers that high, but they just keep going. And if you know them, you might be able to get out of an escape room. So keep that in mind. This is actually pretty hard to figure out an explicit formula for. So if I said to you, like, what's the 50th Fibonacci number in that sequence? That's kind of hard to figure out unless you know some tricks to do it, without just sitting there and just keep adding them together. Here's another example of a...
Sorry.
Do we know where the hockey players are meeting?
No idea.
Okay.
Sorry.
That's okay. That'll be on YouTube. Okay. So let's look at this one. Here's a Fibonacci sequence where they give us the first number, and then they say to get the next number, add 3. So here's the first one, 2. What would be the next one? If the rule is to add 3 to the one that came before it. And the next one? 8. Good. And that's an example of a recursive one. Have a good day.
Sorry.
That's okay.
We're gonna keep talking.
Okay, so that's recursive. Again, not that easy. If I said, okay, what's the 50th term? We want a better way than adding 3 a bunch of times. Okay. But for small values, it's okay. Any questions on this one?
You go through like how I'm not quite getting it.
What the pattern would be?
Like how you where do you plug in?
Oh, this was given.
Okay.
So in a Fibonacci sequence, they have to give you the first couple terms.
Okay.
If they don't give you a starting point in a recursive sequence, sorry, you can't do it. So this was given, and then from there we can just keep adding through. But a better pattern in this problem would be triple it and minus 1. That's the pattern. If you triple the second term, or if you think of this as the position, triple 2 and minus 1, you get 5. Triple 3 and minus 1, you get 8. I know that it was tripling because of this. And then I said, well, if I just triple 3, I get 9. So how can I adjust it? Well, minus 1 from it. And then see if that works everywhere. But we'll talk more about that. Okay, so this one says determine the first 4 terms and the 8th term. I didn't have you go all the way to 15 terms this time because that's recursive. So the first 4 terms and then the 8th one. So sometimes what I do is I just make a table. The position is like what spot it's in, and then the term is the value in that spot. So let's start with the first spot. What's the term in my first spot? How do we know that? It's given. Something has to be given. And what does this formula basically say to do? Multiply by 4 would be this. And then minus 1 would look like that. That's multiply by 4 and then minus 1.
How the other equation was set up?
Yeah, in the other equation, you just switched the 4 and the 3.
Yeah.
Which one are we talking about?
There's just one up there.
This one?
No.
No.
We just that where you said multiply 3 and then minus.
Oh, to find an explicit pattern. Yes, that's the explicit pattern. So in this case, we're not looking for the pattern yet. I'm looking for the value that would go in that spot. So what does this rule say to do? Yep.
Take the one prior and add 4.
Take the one prior and add 4. Is there a better way to write that formula that involves multiplying by 4 somehow? Yes, probably. But for now, we don't have to find it. We just want the value. So can you tell me what would be the value here? 6. And then the next one? 10. And the next one? 14. So there's the first 4. Now, can I jump right to the 8th one using this formula? Do you think 1? No. You can't, there's nowhere to plug in an 8 here unless you figure out the formula that Dustin said, which is multiply by 4 and then minus 2. That is the formula. And sometimes it'll ask you to figure that out, but this time it didn't. So if you figured it out, great. If you didn't, that's fine. Just keep adding 4. So the next term would be 18. And then 20 what? And the next one? And the last one? 30. That's the one they really want. The 30th, the one in the 8th spot, and the first 4. These other 3, we didn't want to have to find them, but there's no way to get to the 8th one without going through them. Unless you figure out a different formula, which sometimes is easy, sometimes it's hard. If I had to go all the way to the 200th term, I would be figuring out a different formula. I wouldn't do it this way. 8 is quick enough, we can do it. Any questions on that? All right, so now let's do what we basically just did in that last problem. Let's take a problem that gives us a recursive formula and see if we can convert it into explicit. I think the easiest way is to take what they give you and write out the first maybe 3 or 4 terms. So then you have something you can look at, and once you think you have the formula, test your formula on that. So we're going to try to find an explicit formula for that. All right, so first term, that's given. It's 3. What does that rule in the red box say to do? Like if you just kind of simplify it as much as you can, so somebody in like 3rd grade would understand it. What is it? Add 5 to 1. Yeah, add 5 to the last one that you have. Just add 5 to the one before it. So if we want the second term, add 5 to the one before it, and what do we get? 8. If we want the third term, add 5 to the one before it, and we get 13. Let's do one more. What would be my next term? 18. So those are the terms. The goal is to figure out a different formula. There's your position numbers. 1, 2, 3, 4. We're looking for something we can do to this number to turn it into that number. Does anyone see? Multiply by 5 and subtract 2. 4 times 5 is 20, minus 2 is 18. 3 times 5 is 15. 15 minus 2 is 13. So there's our pattern. And how would you write that? Yeah.
5A and minus 2. 5A.
Well, we don't want to use, if you write anything like this, you're depending on the one that came before it. So we don't want to have anything like this in our formula.
And then 5n.
5n, yeah.
Minus 2.
Minus 2. That's the formula. N is the term position you want to know. So if you want to know what number is in the 10th spot, you plug in a 10. 5 times 10 minus 2 give you 48. That's the number that would be in the 10th spot. So when you write something explicit, that's what it should look like. It's usually a number times n plus or minus a number. At least that's kind of the simplest formulas. Any questions on that? And if you're still not sure, well, how are people just coming up with times 5 and minus 2? There is a way to come up with that without just trying to guess. We can figure that out. And I'll show you the method for doing it, and we'll come back to this problem and try it. But there is a way to get this without just trying to guess. We already kind of talked about this, but the Fibonacci sequence. In fact, I don't know if I listed up to 6 of them, but we listed the first few. This is the pattern for the Fibonacci sequence. This says to get any term, take the one before it and the one before that and add them together. This is where it can start to get kind of complicated. That's not too bad. But if I said to you, like, all right, take the one before it and triple it. Take the one before that, quadruple it, and then add them together. That would be a tough pattern to figure out. You probably wouldn't be able to guess that very easily. So that'd be a little bit beyond what we're going to do. But let's just write the first 6 in case we didn't go that far. What was the next term? 2. And then, so we're finding the third term. No, we're finding the fourth term now. So if you wanted to think about it in terms of the formula, the fourth term is equal to the 4 minus 1 plus 4 minus 2. That's how you get the fourth term. So what would be my fourth term? 3. It's the third term plus the second term. And the next one? And one more. 8. I think we already did them that high anyway. So the Fibonacci sequence is a special type of sequence. I think the name is, it's called a Lucas sequence. And in general, that type of sequence is where you just add the two numbers that came before it to get the next one. What's special about a Fibonacci sequence is it starts with 1, 1. But you could start, with something like 2, 5. Actually, it wouldn't get you in the same pattern. So the next number would be 7, and then, and then you could do 12, 19. Just adding the two numbers that came before it to get the next one. Any question on what the Fibonacci sequence is? And it goes forever. This is an example. It doesn't stop. It just goes higher than you want. All right, so the last two things we're going to look at are another way we can describe a sequence. One way we looked at it is if it goes on forever, that's called infinite. If it stops, that's called finite. Well, that's looking at how long it is. Another way we can classify it is how do you get from one term to the next? Here's an example of one type of sequence that we're going to look at. Here's an example of another one. What's the pattern in the top one? Multiplied by 2. That is not called an arithmetic sequence. That's different. What's the pattern in the bottom? Add 2. That is an arithmetic sequence. So an arithmetic sequence is when you can look at a number, look at the one before it, and subtract them, and you get the same answer over and over. What's 12 minus 10? 2. What's 10 minus 8? 8 minus 6, and 6 minus 4, they're all 2s. So if you can subtract one number from the one before it, and you get the same answer every time, that's the number that you added to get from one number to the next. And when you subtract two numbers, that's called the difference. So if you get the same difference every time you subtract two numbers, that's called the common difference. And that's the number that you added to the term before it every time to get to the next one. It's the difference between the two. Now, if you look at that sequence where I was doubling, that does not have a common difference. If you subtract these, you get 12. If you subtract those, you get 6. And if you subtract those, you get 3. You're not adding the same thing to get from one number to the next. So there is no common difference there. And recursively, this is how you write a formula for an arithmetic sequence. You take the term that came before it, and you add, well, it could be subtract. It depends on the problem. You could add a negative, and that would be like subtracting. But you take the one that came before it, and you add a value. Now, because adding a number over and over and over, that's a pretty simple idea, just add 2 each time, there is a way to figure out a formula that's explicit if all you're doing is adding the same number and over and over. And I'll show you what it is. It's going to depend on 2 things. First, it depends on what are you adding. You're adding 2 each time, you're adding 3, so you have to know what you're adding. And the second thing you have to know is, where did you start? What was the first number in the sequence that started this whole process? As long as you know those 2 things, you can figure out the formula. So the explicit formula, when all you do is add or subtract a number over and over, is the first term plus n minus 1 times d, where d is what you add each time. D is the common difference. So we're going to go back to one of the problems we did earlier and see if we can just use this formula to figure it out. Now we don't have to guess, oh, it's multiplied by 4 and subtract 3. You know, we're not going to have to try to guess that anymore. This will give it to us automatically. So it's the first term plus n minus 1 in parentheses times d. Let's go look at this one. All right, so let's look at these values. What's the first term in that sequence? 3? Right here. So yeah, first term is 3. So let's write that down. And what's the common difference? Like if you do 18 minus 13. Yeah, the common difference is 5. Okay, so we've got the 2 pieces of information we need to figure out that formula, which now we're going to get by using what I just showed you. Can someone remind me, what was that formula again? A sub n equals...
A sub 1 plus n minus 1 times d.
Let's fill it in and see what happens. So a sub 1 is 3 plus n minus 1. And what's d in this case? 5. Okay. What property do I have to use with the n minus 1 and the 5? Distributive. Okay. If I distribute that up, Sam, what do I get?
You get 5 and minus 2.
Minus
Oh, 2 and no.
5 times negative 1. Negative 5.
Yeah, sorry, I was trying to skip ahead.
And what do you get when you combine like terms there?
5 and minus 2.
5n minus 2, which is exactly what we got before. Except now, we didn't have to try to guess and look at a pattern. We could do it very systematically and figure it out. So that's the formula you want to use anytime you have a pattern where you add the same number over and over. So any question on that formula?
Negative for you subtract.
Yep, if you add, the only difference if you subtract is this would be a negative. Yep. All right, let's try this one. Actually, that's not doable because I didn't tell you the first term. So I need to tell you that. Let's say, there we go. So now, you don't even have to list out the first 3 or 4 terms and try to see a pattern. All you need is these two things. What's the first term in that sequence? 5. And what are they telling you to add each time? 3. Just fill those two numbers into the formula. So a sub 1 plus n minus 1 times d. Okay, a sub 1 is 5, and d is 3. Now you should do that up. Okay, distributed as combined like terms. Okay, let's see, what are we going to get for the number with n? Yeah. 3n. And what about the number that I'm going to add or subtract? In this case, I think it's going to be add 3n plus 2. Yep. If you want to check if that formula works, you could follow this rule, write out the first few terms, and then test it. But that will work without having to write anything out. Questions on? All right, let's try this one. The first two terms. Now, a lot of times 2 terms is not enough to see the pattern. Because I could say, oh, the pattern here is divide by 4. Right? Because if I divide -8 by 4, I get -2. But I know it's not divide by 4 because they said it was arithmetic. Which means you either add or subtract to get to the next term. Right, let's see if we can come up. I know we could figure out the 5th term. It's not that hard. Just keep minusing 6. Or, I'm sorry, adding 6. Well, let's see if we can come up with a formula. What's my first term in this case? -8 plus, what are you adding each time? I know it's only there once, but it's arithmetic, so it is going to be the same every time. You're adding 6. Okay, what's 6 times n? 6n. And 6 times -1? And what's -6 plus -8? -14. There's your pattern. So now you can figure out whatever you want. They want the 5th term. What's 6 times 5? 30. And 30 minus 14, there we go. 16. Could I have found that quicker just by adding 6, and adding 6 again? Yeah. But if they wanted to know the 532nd term, well, now I can find that just as quickly. Just use my calculator. Fill in whatever you want for n. All right. Let's try this one. All right. So they give you the 3rd and the 8th term, and they tell you it's arithmetic. You need the first term and the common difference. It's definitely a subtraction. And what do we know about the amount you subtract each time? It has to be the same. So there aren't that many options to get from 13 to 3 in 1, 2, 3, 4, 5 steps. Yep, you're subtracting 2 each time. 11, 9, 7, 5. So we know that the common difference is a -2, because we're going down by 2, but I still need the first term. So, second term would be 15, and what about the first term? There you go. So you just work backwards to get the first term. And now we can write the formula. A sub n equals a sub 1 plus n minus 1 times -2. What's n times -2? -2n. And Cameron, -2 times -1?
2.
Plus 17. There you go. That should be the pattern. Let's try it. Let's try for 5. What's negative 2 times 5? And what's negative 10 plus 19? Perfect. So that seems to work. It's a little tricky because you didn't have the first term, but you had enough information you could work backwards to figure it out. All right, so the last type of sequence we're going to look at is geometric. Now, geometric is when you multiply to get to the next term. You don't add or subtract, you multiply. So let's look at something like now, I already looked at this when I said, let's try subtracting, and you're not subtracting or adding the same amount. So let's look at dividing. What's 24 divided by 12? What's 12 divided by 6? What's 48 divided by 24? 2. So the pattern here is, if you take a term and divide by the one before it, you should always get the same answer. And that's called my R value. R because it's a ratio. And a ratio is a fraction. You divide two things. So in a geometric sequence, or you can call it a geometric progression, it's just the same. To get any term, you multiply the previous term by a number. What you multiply by has to stay the same for the whole sequence. If you want to multiply by 2, that's fine. Multiply by 2 the whole time. So this is how it would look recursively. To find a term, take the one before it, that's what n minus 1 means. Take the one before and multiply by r. So they don't call it a d this time, they call it an r, but it's a similar idea. R is called your common ratio. And to find your common ratio, take any term you want and divide it by the one before. So in this case, it's 2. And that's what this formula says. Take any term that you want and divide it by the one that came before it. So a sub n plus 1 means take a term, and a sub n is the one that's right before n plus 1. You could write that different ways. That's just one way to write it. But the concept is take a term, divide by the one that's before it. Now, there is an explicit formula to figure out a geometric sequence, and that's going to be the last one. Let's look at the example first and see how hard it is to figure out just by looking at it and trying to guess. And then I'll show you that. So leave like 1 or 2 more lines to write that down. Let's look at this one. Now, because it's geometric, you know you are multiplying by the same thing over and over. So I'm hoping most people can get the table. What I don't think most people are going to be able to get is the formula. What would be the next term after 12? After 12.
Negative 24.
Yep. And the next one? Positive 48. And the last one? Okay. Now let's work backwards to get to the first one. 3. Now, I'll give you a hint that the formula does have something to do with the first term. And it has something to do with what you multiplied by each time. What did we multiply by each time?
-2.
-2. The formula has something to do with those numbers. But it's not as easy as like triple it and then -2 or something like that. Does anybody think they see what you can do to this number to turn it into that number? Again, another hint I'll give you is the formula has a variable, but it's a variable in an exponent. It's kind of like the one we did with -1 to the n, 2 to the n, whatever that was. Right here. It's kind of like something like that. It's going to have a variable in the exponent. So this one's actually kind of close because this is alternating negative, positive each time, and it's doubling it. So that's kind of like our formula, except we want to start with 3. I think that was the first term. Does anybody think they see it? It's hard to figure out, but once I show you the formula, it makes it very easy. Then you don't have to do this thinking. You can just use the formula and you're done.
And -1 is the quotation,
Or parentheses, yeah.
and then 1 plus n,
Okay.
and then another is then times 3 n, and then
N to the n?
Yep.
All right, let's try it. So let's try it for the number 2. If we plug in 2 for n, we would get -1, and I'm plugging in 2. So that would give me 2 plus 1, and this would give me 3 to the 2. Well, that's -1 cubed, so that's -1. 3 squared is 9. -1 times -1 times 9. I'm not sure that gave me the right number. That's the formula you meant, right?
yes, I think I see what I did wrong. Isn't n supposed to be right next to 3 then?
So you mean like 3n?
Yeah.
No, I won't work with a 3n. But you had the right idea. We did get the right sign. We got a negative, but we wanted to get. You're just slightly off. You're kind of close, but let me show you what it is. It does have an n plus 1 in the
Can I have your
exponent.
attention, please?
And-
All varsity football players should be dismissed at the...
So you were right to put like an n in the exponent and then a +1 or a -1. You can actually do it a couple different ways. But that's the formula. Let's go try it. So it's the first term times r to the n minus 1. So first term times r to the n minus 1. Okay. What's my first term? 3. What's my r value? -2 to the n minus 1. Let's see if it works. Let's plug in 2. See what we get. What's 2 minus 1? 1. What's -2 to the first power? 2. Anything to the first power stays the same. So -2 to the first power is -2. And what's -2 times 3? There you go. So it's first term, r to the n minus 1. That's the pattern. So you kind of had some of it here. You had the exponent, and you had a negative in there raised to a power. So you're kind of close. It's hard to figure out without that. Right? And that's always the formula for geometric. Are there other types of sequences that aren't geometric or arithmetic? Yeah, there's all kinds. But those are the two that we focus on. Any questions on? Okay, so that's 11.1. So tomorrow we're going to look at what happens when we add up all the numbers in a sequence and find the answer. For a small sequence, that's easy. For a big sequence, we need a way to do it. Okay, so there's a lot of odds here. So it's 1 through 5, 9 through 13, those are odd. 14, that's the only even. And then 17 to 27, odd. And 31. And we'll take a look at that tomorrow.